Other question, consider a gold nucleus to be a sphere of radius 6.9 Fermi, in which protons and neutrons are distributed. Find the force of repulsion between two protons situated at the largest separation. So in this case, what we have to do, in case of the nucleus, I am drawing the nucleus. Here it is given the radius is 6.9 Fermi. So definitely here here the proton. So one more proton just diametrically opposite. Here I am going to consider. So that is your 6.9 again, that Fermi. Here again the proton. So find the force of repulsion between the protons situated at the largest separation. Largest separation is, so largest separation, that is R is equal to 6.9 plus 6.9. That is your 18, 1, 13.8 Fermi. That should be your separation. So the force of repulsion between the protons is equal to the same thing, k q1 q2 by r square. So I am writing 9 into 10 to the power 9 in place of k, and q1 is your proton, that is having the equal charge, that is of the magnitude of charge is of that equal to the electron, that is 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19 by separation 13.8 Fermi whole square. Fermi, 1 Fermi. So that if you are going to calculate, 1 Fermi is equal to 10 to the minus 15 meter. So ultimately after calculation, by calculation, that much, 1 Fermi is equal to 10 to the minus 15 meter. You have to just calculate, and after calculation you will get F is equal to approximately 1.2 Newton. 1.2 Newton. Another question, two insulating small spheres are rubbed against each other and placed 1 centimeter apart. If they attract each other with a force of 0.1 Newton, how many electrons were transferred from one sphere to another? So here, you know that we have to find out how many electrons are going to transfer. So in fact, Coulomb's law of electrostatic force is your 1 by 4 pi epsilon naught. How many electrons we are not knowing. So n, I am taking n number of electrons, n q square by separation is your separation given 1 centimeter. That is your 10 to the power 1 centimeter square, means after converting in meter it was minus 4 meter. Right? Now here F is given 0.1 Newton. That is your 9 into 10 to the power 9 into n q. Q, how much should be the q? That is 1.6 n square, 1.6 into 10 to the power minus 19 by 10 to the power minus 4. So n square you have to find out. After n square is equal to, what will happen? This 0.1 into 10 to the power minus 4 divided by this and this. N square will be your approximately, after calculation, you just calculate, after calculation you will get n square is around after calculating this one, n is equal to, after taking the root, 2 into 10 to the power 11 electrons. 2 into 10 to the power 11 electrons are transferred. This much electron transferred, then only the force will be 0.1 Newton. Another interesting question, 10 positive charged particles are kept fixed on x-axis at a point x equal to 10 centimeter, 20, 30, and so on 100 centimeter. The first particle has a charge of this much, 1 into 10 to the power minus 8 coulomb. Second has the charges, third is having this, and so on. The 10th particle has the charge of 1000 into 10 to the power minus 8 coulomb. Find the magnitude of the electric force reacting on a 1 coulomb charge placed at the origin. The situation is like that. Here the origin, here say the at the 10 centimeter, one particle, again from the this again 10 centimeter means total 20, another particle, again 10, another particle, another 1 2 3 4 5 6 7 8 9 10, and charges are also all the 10 centimeter. Charges are given of this point, this point, this point, this point, this point. So here the charge is 1 into 10 to the power 1 into 10 to the power minus 8. Here the charge on this particular particle charge is 8 into 10 to the power minus 8 coulomb. Here the third particle is having the charge 27 into 10 to the power minus 8 coulomb, and so on. The last one, 10th one, is having 1000 into 10 to the power minus 8 coulomb. Now the total force, if say q coulomb charge, here it is given, if 1 coulomb charge is placed here at the origin, 1 coulomb charge is placed, then what will be the total force exerted on this 1 coulomb charge due to this particular surrounding object, having a charge object? So F will be F1, इसके पहले के फर्स्ट के चलते F1, सेकेंड के चलते फोर्स F2, then F3, and so on. The force due to the 10th particle having the charge F10. So ultimately what will be the numeral value? So F will be is equal to, in place of that K Q1 K means 1 by 4 pi epsilon naught, and then here the charge is 1 into first one, that is 1 into 10 to the power minus 8 coulomb by 10 centimeter square means 0.1 square, plus second charge 8 into 10 to the power minus 8 coulomb by distance is 0.2, distance become 0.2 10 yeah, second के लिए point, and the charge is 1 into 8, that distance become 2, 20 centimeter means 0.2, so 0.2 square. Similarly here it is 27 into 10 to the power minus 8 coulomb by 0.3 square, and so on. And the last one is having 1000 into 10 to the power minus 8 coulomb by the distance will be 10 into 10 100 means 100 centimeter, that is one we can write the 1 meter, 100 centimeter means 1 meter, that much square. Now here 9 into 10 to the power 9. Now what we are going to see, if I am going to take out this 10 to the power minus 8 is there, here 10 to the power minus 8, so take out 10 to the power minus 8 common, so here we will get 1 by 0.1 square, that is 1 by 10 square, plus 8 by, here it is 2 by 10 square, here it is we can write 27 in by 3 by 10 square, and so on. Now, interesting fact is that 10 square denominator means we can write it 9 into 10 to the power 9 into 10 to the power minus 8 by this 10 square means 10 to the power minus 1 whole square, 10 to the power minus 2. We are taking out common. So what will be here? 1 by this, then 8 by this 2 square, that is 4, plus 27 by 3 square 9, and so on. Last one, 10th one will be 1000 by your how much it is? 100. This much, 100. This one. If you are going to cut, what will happen? 2, 3, and so on, 10. So ultimately, what we will get? 9 into 10 to the power minus 9 into 10 to the power minus 8 by 10 to the power minus 2 within bracket 1 plus 2 plus 3 plus and so on, and that will be the 10. So it is how much it is? 9 into 10 to the power minus 17 by 10 to the power minus 2. And here, if you are going to add 1 plus 2 plus 3 plus 4 plus 5, 6, 7, 8, 9, 10, you will get 55. If you are going to add, you will get a 55. So just you calculate and you will get the answer. That is around after calculation you will get 4.95 into 10 to the power 5 Newton. After calculation you will get it. Right? That is your, after calculation you will get it. Here it is 9 plus 9 is there. Plus 9, here plus 9. So plus 9 and this this will be the 10 to the power plus 1. That should be 10 to the power 1. So calculation is like that, and after calculation you will get the 4.95 into 10 to the power 5 Newton. That should be your answer. Right?